like acting in Mr. Thomas.
Why did you change the confidence?
As like the bitchy.
I have no clue. 13 and 14 are the big ones. I mean, we did 15. Is it bad that when I said snap?
Okay, let's get going here. 95% confidence. No, number 11. 95% confidence interval for mean of a population is computed, and the random sample is said to be 9 plus or minus 3. We may conclude that. This is a bit open-ended, but we are 95% confident. Confident that the true mean of the population is between 44.2 and 54.2. No. 6 and 12. There's not really a whole lot to this question, is there?
Is that it?
That is it. The question is, can you write a conclusion?
Okay, 12. Yeah.
What's the difference between like 11 and 7?
Not much, really. It's still like, interpretation of the confidence interval. I mean, we could have just as likely said that if the sampling procedure, or if many confidence intervals were constructed, 95% of these intervals,
So both can be used for these types of
yeah, would contain the true value of the population mean.
So conclude and interpret.
So either one of those two.
Yeah. Yeah.
Write down. Is it okay if I use CI for a confidence?
Absolutely.
So just like how we did number 11, can we do that for number 9 as well, or is that number 9 last number?
Yeah, you could do the same thing for 9.
Does either one?
Either or, yeah. Yeah. Basically, sentence 1 here and sentence 2 say the exact same thing. The second sentence is a little bit more to the actual meaning of a confidence interval. And the first one kind of links the confidence interval more to the context. But you're using confidence to define confidence interval, so it's a little strange. You don't necessarily want to do that. 12. A 95% confidence interval for a mean reading achievement score of a population of third grade students is between 44 and 54 twos. Suppose you computed a 99% confidence interval. Would the new interval be narrower or wider? Well, since the confidence is increasing, the interval would be wider. If you want to be more sure, let's put it this way, like, if I want to be more sure, I would want to include as many values as I can. Put it in the way that we did it in class. Like, if I wanted to be sure, if I wanted to know the mean income of Taft High School's parents, and I wanted to have 100% confidence, I would give an interval between $0 and $2 million. right? That's a wide interval that has very little risk of me being incorrect, but it also has very little generalization or very little information.
So if you want to be more confident, your interval has to be bigger.
Yes, exactly. It's like saying, you can give me a range for how many jelly beans are in that jar. Okay. If you want to have less risk, if you want to be more confident, would you make more guesses or less guesses? Definitely. More guesses means bigger interval. Okay. Does new interval involve more risk or less risk of being incorrect? This would give us, has less risk of being incorrect. Yeah.
Can you also, like, the reason it gets wider is because the T star would be bigger, so it'll be multiplied out.
Yeah, that's mechanically that's true. Yeah. Theoretically, it's kind of that idea of what the definition of confidence is. They're related. Let's put it that way.
Like kind of a pop quiz we gave period
Mhm.
one, how one of them that had to do with like is the interval like wider or
Mhm.
like one's shorter.
Yeah.
What was the other one said? Was something kind of the same? Said something weird?
Yeah, I don't remember exactly. Sorry.
Nice question was the marginal.
Okay, let's move on to 13 then. 13 is construct an interval. 13. U.S. Forest Service, I gotta read slowly, is considering additional restrictions on the number of vehicles allowed to enter Yellowstone Park. To assess public reaction, the service asks a sample of 150 visitors if they are in favor of the proposal. Of these, 89 say yes. Construct and interpret a 99% confidence interval for the proportion of visitors, of all visitors in Yellowstone, who favor the restrictions. Okay, so we're looking at P's and P hats. So P is equal to the proportion of Yellowstone.
Wouldn't be all Yellowstone.
Yes. Who favor restrictions. I guess additional restrictions. And P hat, that's, what happened to my hat? P hat is equal to the proportion of
150 visitors.
150 Yellowstone visitors who favor additional restrictions. Okay, assumptions. Number one, is this an SRS? Yeah, I think so. It says, yeah. The problem states that this is a random sample.
We have to do the whole thing.
Yeah. Independence. Okay. For our interval to hold true, 10 times 150, which is 1,500. Okay. Are there more than 1,500 visitors to Yellowstone?
Most.
I think the answer is yes.
The answer is yes.
Yes. Yes. But that's, you bring up a good point. There are more than 1,500 visitors. I didn't think of that. That's a real clever
Would
one.
Warner's response get points?
Huh?
Would Warner's response get points on the test?
Yeah, I think so. That's points. 20 points to Gryffindor.
Start questioning what you're reading.
1,500 visitors to Yellowstone. Normality. What's normality here?
Can we use
And it's greater than 30.
Yeah,
It's greater than 30.
so CLT plus.
CLT apply.
No, wait, no. This is a proportion, so NP
Oh,
and
yeah.
NQ have to be greater than.
That's true.
There you go.
Oh, yeah.
These aren't means. We have to use proportion. Okay, so the proportion,
You finally gave us a chance to use it. We can't use it.
proportion conditions. Normality. So, n times p hat. That's equal to 89, right? Which is greater than 10. Yeah, right? Look at these people. Aren't they crazy? 454. N times quat.
Phone here?
Behind you.
Yeah, behind you.
No, like outgoing.
Outgoing?
Yeah.
No. Got my cell phone. You want to borrow my cell phone?
No, I don't want to use my cell phone. I gotta talk to the screaming parent.
Oh, yeah.
Like,
You know, is Bridget still in?
She has a phone.
No, she can get you.
Wait, I thought these phones can go out, so we can just download
Okay,
it.
we just have to dial in.
No.
They're pretty much just interlocked to the school.
I wouldn't know.
No, using that.
Wait a minute. Can I still do the intercom? Do we have it?
Yeah, we do.
No, we don't usually, no. Actually, we don't.
Yeah, we do.
Yeah, we don't care about these
We
outfits
don't.
though.
The thing is, though, I can actually make things an intercom. If I learned, I would use it. I don't know.
You don't want to use
No,
it? I know how to
90.
do it.
61
Body self-service.
is greater than 10. Okay. Since both are greater than 10, the sampling distribution. Really?
Speaking of someone.
Aloha.
It also means high.
Okay. No. No. Sure. All right. Sure. What movie? Huh? What? I don't know what we're talking about here. Oh no, it's called The Wind Rises.
What?
No, that's the name of the airplane. It's showing at the ArcLight, Sherman Oaks. Let me know if you go, because I will go again. Okay. Bye.
Much respect.
This one. Lego.
Oh, Ms. Brownell said yes.
Lego.
Yes.
Actually, me too.
I don't know.
Okay, so the sampling distribution is approximately normal. Great, we have satisfied all of our conditions. This is great. This is why I like dealing with proportions more than I like dealing with means.
It's easier to say it's okay.
Yeah. There's a definite rule. Unlike normal. Normality for means.
It's like maybe it's okay.
Kind of.
This is
No fuzzy logic.
Can you use these things?
Is that how you use it? It starts
I was
88.
like, dial.
Yeah, dial
with
88.
7 in?
Yeah, just use
Why would you want to do that?
So you can't, so
So
parents
you
can't
restrict
track
Can I
you.
get your number?
It hides your cell number.
Huh?
It hides your
blocks
cell
Cell
number.
number.
Wait, tell me again.
Star
Star 67.
67.
Yeah, this is the point.
Wait, 69?
7 is
Bruce Wall, this is what we can have.
67.
yeah.
See what this
Here,
stuff
Dami, Dami, star
See what
67.
this does to them? What you're doing?
Dami, star 67.
Yeah, this is
Yeah.
20.
Okay.
Star 67.
Oh, I thought I meant use your phone. Here, how about you just use your phone? You start 67.
Me?
Yeah. So when they call you back and say,
No,
hey,
I'm gonna call you.
you're gonna say por qué?
Star
Oh,
See if star 67 works or star 69.
67.
No,
Push in front of me.
67.
Hate when
Now you use that at 67.
zero.
You just go outside and jump off of it.
And at the same time, this entire thing is all recorded onto our video.
There you go. 67.
Here. Star 67.
Hey, give me your phone.
It doesn't work. It's not connected.
Mom? Star 67 and number.
And then the
right?
number, yeah.
Yeah, it's 67.
Wait, what was the number? Oh, hold on. What's the number?
Oh my god.
We are not
See,
touching.
this is the thing with the iPhone. You can't multitask. Yeah, Android. 344. Okay.
Oh, let me write this down for
I
you.
got.
There's a whiteboard behind you, right?
What did I say?
344.
You're gonna put the calculator.
Alright.
Okay.
Feel free. This is all in our recording.
I know.
Thank you, Ms. Furry.
Yes. We'll see you later.
Star 67 versus star 69.
One sample T Z interval for proportions. Let's get our numbers. What do we need? P hat?
0.592.
Nope. 89 out of 150. Q hat? 61 out of 150.
I thought you were gonna start one decimal place, and that's fine.
Z star. What is Z star? 99% confidence interval. Is that 2.456? 2.576? Thank you. And equals 150. And equals 150. Great. Let's do this. Confidence interval. P hat plus or minus square root
Wait, isn't it Z star times?
Z star. Thank you. Z star 2.576 P square root of P hat, which is 89 out of 150.
So if we use fractions, we have to use it through the whole thing.
Yeah. 61 out of 150 divided by 150. I feel like I'm missing a percent, one of those. Is that right? Yeah, there we go.
I feel as though.
I feel like I should write this, actually.
Getting the Z star is the same for the reason, right?
Yeah.
I feel like that
It's just
150.
very complex. It's the same thing as linear.
Equals 89 out of 150. Okay, I should write 150. Plus or minus 2.576 square root of 89 out of 150. 61 out of 150. Whole thing out of 150. Well, thank God your calculator does fractions now. 2.576 times, I hate you, calculator. No, I'm just kidding. I like you. 2.576 times You are correct. Thank you. Square root. Now we do the fraction. The first one is 89 out of 150 times 61 out of 150 divided by 150. All that for 1033. Hmm?
Hey, what's that one for the for the fractions?
Alpha F1. What was 89 out of 150?
0.5933.
0.5933.
Yeah.
Plus or minus, what did I get? 1033. There we go. Margin of error. You have a 10% margin of error. That's not nice. But actually, if you look at that, what is this?
0.49
Oh, 0.49.
and 0.6966. Or
0.6966?
Yeah.
Okay. Look at this confidence interval.
That's freaking huge.
That's big. That's a big confidence interval.
It's 99% confident.
Yeah, we are 99% confident. That's for sure. But
But
can you say that a majority of people support the restrictions? Is it possible that P is less than 50%? Yes.
Anything is possible.
Well, I mean, according to our confidence interval. Let me. You know what? Before we get to that question, let's give our write-up. Yeah, we are 99% confident that the proportion of Yellowstoners patrons who favor restrictions is between 49% and 69.66%. Okay, that's great. Did we fail any conditions?
no.
No, so we're good. We're good here.
I get stolen feet.
But not only was that libel, I was like blatantly racist. Oh my god. What are we doing? Why are we here?
You don't deserve the
Look what you're doing to us. Right?
Okay,
stats.
is our entire interval above 50%?
No.
No. So this is just an additional point.
So this isn't necessary, right?
Yeah, this is not really what we're going with, but who knows? The additional point. Our interval is not completely above 50%. There is a chance that the true, or that the proportion of Yellowstone patrons who support the restrictions is less than in other words, to be a little more concrete here, this sample does not show that Yellowstone patrons are in favor of additional restrictions.
52%.
Yeah.
Are we talking about the 89 out of 150?
Well, we're talking about this right here. Our lower bound is 49%.
Right. So,
Okay. So remember what we're saying is we don't know exactly what the true proportion is. We just know the true proportion is somewhere between 49 and 69.6. It could be 49. We can't say any more than that. The actual proportion is somewhere between 49 and 69%.
So,
We don't know which one of those numbers it is.
so if there's like this question, because I know in the homework there's something like that where it said like, is it possible for the proportion to be less than 50%? What do you say? Is a slight possibility because
Yeah.
the lower bound is
Not a slight possibility, just there is a possibility.
because the lower bound is lower than 50.
Yeah.
So if, I didn't really hear what Haley said, but I think it's the same thing.
Mhm.
If it's asked to be like 48%, would you still be able to say that it is possible? Just logically?
48%?
If it was 48%, we
Yeah.
say there is no. It's unlikely.
It's unlikely that the proportion that supported the restrictions is 48%.
So.
It's unlikely, but it's still possible.
It's still possible, but it's unlikely.
So, if the percentage they're asking for is within the bounds, you say that there is a possibility, and if it's not, you say it is unlikely.
Yeah.
Because it's just confidence.
Yes.
They're all technically possible.
Yes. We don't know. Yeah, it goes back to that thing. We don't know what the actual parameter is. We just know the actual parameter. I love that song. We know that the actual parameter is somewhere between 49 and 69. We just don't know which one. Okay, last one. Yay. How long have we... 27 minutes. We've actually only done like 10 minutes of math. No.
They're gonna have a lot of fun with this.
No. Okay, pharmaceutical manufacturer does a chemical analysis to check the potency of products. The standard release potency for cephalathin crystals is 910. Yeah. NSA, whatever that is, of 16.
I googled it. It means analysis.
She wrote this.
Analysis.
An analysis of 16 lots gives the following potency data. Calculate and interpret, thank gosh. Calculate and interpret the 99% confidence interval for the proportion, for the population mean using T procedures. What is the margin of error? 14. Error. Okay, in your calculator, please. Do you need a key?
No.
Okay.
I'll be back tomorrow.
All right. Bye. Error.
They have no idea what just happened.
Do you?
Hey, this is a pretty tight group of data here.
Wouldn't that make it better for us?
Yeah, that's excellent. We love this. Whoever did the measurements here is spot on. Except for that 921, whoever that was. He's fired.
Wait, I thought you made them.
Don't you make these?
Not all of them.
Oh, okay.
A lot of this data comes from actual
So
stuff.
you just surf and be like, let's look for some data.
Sure.
So you get actual stuff.
I would rather get actual
So it makes sense.
data than fake data.
I still can't believe you went to that one Starbucks and actually took the time to go through all the prices.
Yeah.
Oh, which one?
It was like a question we had with me on last time ago.
Okay. Calculate and interpret a 95% confidence interval. We need T star 95. T star 95. Is it 99?
99.
T star 99. T star 99, no. T star 15.
Oh, 15. Why the hell would it be 99?
947? Wow, that's huge. That's a really big number. Did you get a different number, Tanya?
Yeah, I don't know.
Would you?
I'm probably wrong.
Yeah.
Where's the con for these? Anything's possible.
Don't doubt yourself. Just recalculate. And
This is wrong too.
2.947.
I'm just curious, but do you look at that?
yeah.
Just forget always.
But I didn't look at.
Last year.
Yeah, I haven't looked at this worksheet in a while.
Boom.
Oh, I did it.
Boom.
There we go. Okay, here is our number crunching. So we want a 99% confidence interval. So the confidence interval is equal to 907.75 plus or minus 2.947 times 8.481 divided by the square root of 16, which I know is 2. Wow, it's 4.
Really?
Wow.
Our calculus and statistics teacher.
Wow.
This was number 4. Assumptions that is
Okay,
At the
907.
end, and you could have the "I'm tired" excuse.
That's true. I am kind of tired.
That's the excuse.
What do we get for the, yeah,
Wait, isn't that was recording?
In the beginning of the question, it says the standard release is 910. What is that number?
that's what they expect that's what they expect to be the release note.
Oh, it's like the expected mean kind of.
Yeah.
So does that have
Any part in
part
that?
of this?
Well, let's see. What's our confidence interval? Or what's our margin of error? 248? 2.6.
6.25.
25? 6.25? Okay. So that means our confidence interval, and then we'll get to Faraz's question because that's
So
really.
we're gonna keep it as 4 though? I mean 3.
And 913, 914? Okay. Okay, so in other words, the actual potency could be any number between 901 and 914. Okay. So now when we get to part B, does the result support the claim that the potency is 910? Is it possible? Yes, it is possible. Okay. Our evidence supports the claim that the potency is actually 910. Now, if 910 was not in the interval, your evidence would not support the claim. All we know is that
So it's basically, is it in the interval or not?
exactly. It's in the interval, we support it. Not in the interval, we don't support it. Okay, the, what is it, the potency level? The release potency? Is, could be any number between 901.2.5 and 914. Since 910 is included in this interval, there is a possibility that the release potency is 910. Yeah.
I said that saying the release potency as 910 is kind of generous on their part. Would that still be, would that be incorrect because it's on the higher end of the interval?
No, it wouldn't be correct because it doesn't matter where in the interval it is.
So the higher end could be 910 and
Yeah.
still be split.
The data supports 902 just as much as it supports 905.
Okay, but I was wondering what makes this different from the last problem where because where it was 50%.
Mm-hmm.
Well, I think we were talking about the last question. Yes.
Well, we said it supported it.
Because
It
it
could
was
be.
between like 49 and 60. Yeah, we said so that was in there also.
Yeah.
Yeah,
Well, here's the thing. Compare this with what if this interval said, for this question number 13, what if this interval said 64 to 73?
yeah.
Is there a possibility that, or does your data support that the people who are in favor are more than 50% or not more than 50%?
Yeah.
It definitely supports it, right? Because your entire interval is above 50%. Compare that with this one. The entire interval is not above 50%. So there is a chance that the actual proportion of people who is below 50%. This interval supports 68% just as well as it supports 49.5%. Yeah.
I think balance included, like typical you.
No, they're not, but you're not going to have that issue.
Okay.
Yeah. That's not the kind of judgment call you need to make in this class.
Okay, just wanna
Yeah. Really good stuff. I'm glad you're thinking like that. It's, that's going to make next chapter a lot easier. C, another researcher claims that he knows the standard deviation is 8.2. Who is this guy? Could calculate a 99% Z interval using this standard deviation. Why you gotta really? Who is this guy?
My nice things.
All right. So what do we want? We want the interval. So that's 90. I'm gonna copy this all down. C. This is our confidence interval. What Z star do we need? 99? So 2.576. And the standard deviation is 8.2. What does that give us then for our how much?
76. I got 76.
5.76?
Yeah.
Check him. He might be wrong.
Might be wrong.
5.28.
See? Don't doubt yourself. Support your conclusions with data. Confidence interval is 902.30. 47. 913.
0.03.
Yeah, Alex.
It's 2.576 because it's a Z interval.
Yes. So maybe I should write that down. Z star is equal to 2.576. Good question. And D. If sigma is 8.2, how large of a sample size do we need to reduce the margin of error to less than 3? And I think this is our last problem, so I'll just make a mess down here. We want our margin of error, sorry, this is letter D, right? To be less than 3. So in other words, Z star sigma over root n should be less than 3. Z star is 2.576 times 8.2 divided by the square root of n. You want that to be less than 3. I'm going to do some algebra magic. 2.576 times 8.2, whole thing divided by 3, should be less than the square root of n. And now we'll need some numbers.
That's giving like 49.
It is
47.
How much?
49.
5.8?
If you want.
Okay. It doesn't matter, it needs to be a whole number. Okay, so we would need a sample of 50 measurements. 50, what are these? 50 of cephalathin.
Other than for the least potency for cephalathin.
Crystals is needed to get a margin of error less than 3 units. No idea what the units are.
This is 3.
3.
Okay.
When we're doing a panic, do we always write on the side the margin of error, like ME equals this?
I would. If you put it in the plus and minus form, then that kind of implies what the margin of error is.
Okay. So I was just wondering if you have to put it outside of the second.
Yeah, Frost.
For finding the end, do we need to show any work, or can we just write that, like the formula and then just the answer?
Formula and answer is good.
And then, also when you're writing the answer, like for the interval, is there any like form or way you want us to write that, or just with parentheses and a comma?
Parentheses, comma, yeah.
When you're asking the question on the test, how do we know when to go through like all the steps of panic and like write it all out?
Construct.
Construct and then compute?
So to find answer,
Yeah. Okay, thank you everyone.
Thank you.
Have a great night.